So today we're continuing on, working our way through the tree chart, talking about, today it's actually the formulas, the sum and the difference formula. All right, so what we're going to do is we're going to talk about the why. Why do we have these formulas and what are they good for? Then we're going to build one of them. We're going to derive it from the ground up. So you can kind of see where one of these, I guess there's 6 formulas. We're not going to derive all 6. We're just going to derive one of them, okay? And then you'll be able to kind of understand how that works. We will probably then utilize some of those formulas on maybe, depending on how lucky we are, 3 or 4 problems. And then tomorrow we'll continue on and use all 6 of them and all 6 of those problems and stuff like that, okay? So first the why, then the how, what, then the how, or I don't know how we'll figure that out. These are some examples of what the problems are going to look like. Find the exact value of cosine 165 by using a sum or difference formula. I'll give you a sheet that looks like this here in a second. Let's just say cosine 15, all right? If you don't have a calculator, grab a calculator. And let's figure out what the cosine of 15 degrees is here, folks. Type that sucker in while I take attendance. Or find it on the unit circle. What do you think? Why do you think that? Yep. So, what do y'all have for your official answer? Cosine 15 degrees is exactly? Oh, that does not sound exact. That sounds like a rounded value. Let's go math enter on that sucker.
Oh.
It doesn't tell us.
Yeah.
All right. So my question is, why? Why do I have to have an exact value? Who cares? I've got a calculator. It's got like 8 digits after there. Let's just use that, right? Anybody have
Well, you can't.
Anybody have an idea? Why would I care about having an exact value for an answer? Actually, it's not easier to find. It's easier to get the approximation. You just type in cosine 15, enter. Is it on the unit circle? Is 15 on the unit? No, 15 is not on the unit circle. Dang it. That'd be nice. Half of 30 is the cosine of, maybe it is. What's the cosine of 30?
Pi over 6.
Well, sure, let's try that. What is the cosine of 30 degrees?
You can't do an exact.
What is it? What's cosine 30? I mean, you can just look at the unit circle here, folks. Come on. Root 3 over 2? All right. So maybe cosine of 15 degrees is root 3 over 2 over 2. Let's try that. Type in root 3 over 2, and then divide that by 2 and see if you get that 0.96 number. What do y'all get for root 3 over 2 divided by 2? Okay.
Decimal number?
Yeah, decimal number.
0.866.
That's root 3 over 2.
Yes.
Now divide that by 2 because we're, he said, yeah, 0.433. John, what does that tell you? Does not work. Cosine of 15 degrees is not half of cosine 30 degrees. Next week, or maybe, yeah, Friday or next week, we will discover there is a relationship between the cosine of 15 and the cosine 30, but it's not half. Okay? It's not half the angles means half the cosine ratios. Okay. Well, in school, we use math problems to see if you can remember a process, to see if you can take if you can be organized with your work and see if you can remember how to do different things, okay? But in the real world, all right, math and numbers are used to make something, and then that something normally is used to help somebody else out, and in the process, then they give you money for that, okay? That's kind of what math is used. So in the real world, this problem, cosine of 15, or whatever your math equation is going to give you some answer. Let's just say it's root 2, okay? And that answer is going to be the input into another system, okay? All right, well now I'm going to take that and multiply it or divide it or do something like that to figure out how many of these things I'm going to make, or how much chlorine I should put into this, this process, or how the temperature that I should cook this at, or whatever, okay? So let's just say, for instance, that process is times 2. And let's say if the exact answer was root 2, but what is root 2 on the calculator? I think it's 1.41. Okay. And on. Okay. So if you chop off the rest of those numbers or round them, okay, whether you chop them off here or chop them off later on down the line, what you're going to get, if I just say, all right, forget all that stuff, it's 1.4, you're going to get an answer that's smaller than what the exact answer is, okay? So you've introduced a little bit of error into the situation. Like, okay, no big deal. I'm going to take that number and multiply it by 2. You don't need to write this down, by the way. That's going to give me 2.8. And then normally, then that stuff is the input that we then put into some other process. Maybe the result of this other process is going to involve dividing by the square root of 2. So let's divide that by the square root of 2. So help me out here. What is 2.8 divided by square root of 2?
1.9798.
That's 2.8 divided by square root of 2? Okay, oh wait, but that's the exact answer for square root of 2. We said I want to divide it by, well, okay, that's fine. We'll divide it by 1.97. Okay? Now, that's using the approximation value. What if, and then this is, I don't know, how many millions of dollars you're going to make, or how many millions of units you're going to make, 1.97 million, or that's how many milligrams of whatever you're going to inject into the person. All right, so, but what if we had kept things exact? Root 2 times 2, so that's going to give us 2 root 2. And then we divide it by square root of 2, so 2 root 2 divided by root 2. Hey, when it's exact, we know that root 2 divided by root 2 is 1. That's right. And so then 2 times 1 is 2. So the exact answer, 100% exact right answer, if we had kept exact answers all the way through, is 2. All right? So now you made $2 million rather than $1.97 million. Okay? Or made 2 million units is the proper, or 2 kilograms, or 2 grams, or 2 milliliters, or whatever it happens to be, okay? And so part of the reason why we use exact answers is because sometimes things cancel out. And this is just a simple 1-2 sort of process here. If in reality, normally you have multiple things going on, multiple equations, multiple things, multiple steps downstream which are affected. And I think as we you saw this in your science classes, we've kind of seen this in different areas in math. That is, if you start chopping off numbers here and rounding up here, then that error is going to get bigger and bigger and bigger. Okay? If I multiply this by 10 or multiply it by 100, then that error is going to get even larger. Does that make sense? So, in the real world, this is why exact answers are good mathematically. Okay? In this class, we're going to do it because that's the task at hand. Okay? So, for some of you, a discussion, this part of the discussion may be more relevant and useful to you than all the rest of the stuff we're going to do in class today. I'm okay with that. You have to do this stuff in order to get the homework done. So. All right. So the answer is, how do we find the cosine of 15? Well, it turns out we can do something like, it depends on the cosine of 45 and 30, okay? Because, interesting enough, 45 and 30 are both on your unit circle, and the difference between 45 and 30 is 15. So there's a special formula that we're going to create that deals with finding the cosine of an angle between two angles, okay? And that's what we're going to do right now on paper. So this is the sum and difference formula. So there's the y, now the what, I guess, I don't know. Kind of way to cross that out. So sum and difference formula, there it is. So I'm going to draw a picture here. A lot of this stuff is going to seem unmotivated. That's okay. We're going to work our way down through the list here, and then we'll find that one thing equals something else, and then it's a really great formula. So just play along with me here as we do this. So I'm going to draw two angles. One of them will end at point A, other one will end at point B. Both of these are along the unit circle, so they have a radius of 1. And the angle that goes over there to A is alpha. I'll write that a little bit right here. Alpha, Greek letter, first letter of the alphabet, lowercase there, alpha. This one right here, the angle that goes to side for B is beta, which looks exactly like a B, but has a little bit longer of a tail there. All right, based on stuff that we already know, the coordinates of point A, the x-coordinate would be the cosine of alpha, and the y value would be the sine of alpha. It's on the unit circle. And for B, the x position here would be cosine beta, and the y position would be the sine of beta. So what I'm going to do is I'm going to draw this line AB, a line segment AB, call it AB. And now I'm going to find AB using the law of cosines. Wow, that's kind of a stretch. Do you remember the law of cosines? Law of sines was sine A over sine B equals, or sine A over A equals sine B over B, sine C. Law of cosines was a side squared equals the sum of the squares of the other two sides minus 2 times their product and the cosine of the included angle. I don't remember, that was like b squared equals a squared plus b squared, or c squared equals a squared plus b squared minus 2 times a times b times the cosine of angle c. I don't know if you remember all that stuff. It kind of sound familiar? That's fine. I'll build this for you here. You'll remember it. So here's what we've got. AB squared, so that side right over there squared equals this side squared plus this side squared minus 2 times their product, so 2 times 1 times 1, and the cosine of the included angle. Now that sounds a little more familiar, right? You did it maybe a month and a half ago. So here we go. So that whole thing is alpha. This section right here is beta. So the section between them is obviously alpha minus beta. Probably make it a little beta-ish. There we go. All right. So AB squared equals 2 minus 2 cosine alpha minus beta. Any questions so far? Just play along. Smile, nod. We got this. All right. Part of this level of mathematics is derivations. Just there's no other way around it. Now, stuff like this, deriving it, like creating it from the ground up, or at least kind of seeing that and then utilizing it. Okay, and you continue on this level through calculus, but then there's another level above that where they actually expect you to create these, and you kind of go back and you revisit all of your old math and you sort of understand all of the theory behind what you've done. Now, most people don't get to that level. I almost got to that level. I cut off right at discrete math, but just because I didn't need to take any more math classes after that. But anyway, fortunately for us, some smart math nerds kind of figured all this stuff out,
nice.
And we can just follow in their footsteps. It's always kind of good to follow in some smart people's footsteps. So here we go. Next thing, we're going to find AB. That's the length from here to here, using the distance formula. What the heck is the distance formula? Well, distance formula is, remember, square root.
I know this one.
2
minus x1 squared plus y2 minus y squared. Atta girl. Go.
So in this case, that's going to be AB equals square root. So let's just apply our knowledge here. We'll call this one over here x. This is 0.1, so this is x1, y1. And over here, this is x2, y2. So x2 cosine beta, yep, minus cosine alpha. So far, so good. Somebody else pick it up here. Plus. Call it out to me, anybody. Y2. Sine beta, yeah, good. Minus sine alpha. That's not too bad. Alright. Now what I'm going to do is I'm going to square both sides. So I'm going to multiply the left side by itself. So AB times AB is AB squared. And the square root of cosine beta minus cosine alpha squared plus sine beta minus sine alpha squared times itself. Yeah.
What's on the inside?
Just exactly what it's like. The square root goes away. So I've got cosine beta minus cosine alpha squared plus sine beta minus sine alpha squared. AB squared equals. You don't need to write this down. I'm just going to copy that down up here so that we can see it here. Cosine beta minus cosine alpha squared plus sine beta minus sine alpha squared. Now, side note, you do not need to write this over here down, but I'm curious, as honors pre-cal students, does anybody know, jump down to the final step here, a minus b squared, if I expand that out, that's something minus something else squared. Do y'all remember what that quadratic trinomial is? No from the front row. Anybody in the back or in the sides? Not sure? Now, I'm going to walk you through this once, and then from now on, I am going to expect you to know this because this is, I'm going to be honest, this is an Algebra 1 thing. You saw it again in Algebra 2, so now I'm expecting you to know this. So here we are, expanded, that's A minus B times A minus B.
Oh, yeah.
This thing.
And then you FOIL it out. A times A squared. A times negative B is negative AB. Help me out, class. What's negative B times A? And the last term?
Plus B squared.
Plus B squared.
Wow.
So it's A squared minus 2AB. Alright, so I am going to jump from here to here from now on because I am expecting to know the square of a difference.
I thought you were gonna like say something completely off the wall that I was gonna know.
No.
Yeah, I was like C squared.
Do you all remember what A plus B quantity squared is? Very similar.
C squared, but all pluses.
That's right.
Plus 2AB.
Good job. Now, can we apply that formula up here where this is the first thing and this is the second thing? It will, that's okay. So it's always, so look at this one right here. The first thing squared, so I'll write that as cosine squared beta minus 2 times the first thing, so that's cosine beta, times the second thing, cosine alpha, plus the second thing squared, so cosine squared alpha. That takes care of the first expansion. Now we'll expand this one. Sine B minus sine, or sine beta minus sine alpha. So, same process. It's the first thing squared. So sine squared beta minus 2 times the first thing times the second thing. So sine beta sine alpha. Plus the second thing squared. Sine squared alpha. Everything now it's going to start contracting. Alright? So let's see here. We've got a couple of things that I don't feel like rearranging them, so I'm just going to underline them in a slightly different color. Sine squared alpha plus cosine squared alpha. This is a formula, or an identity actually, that we learned yesterday. A little bit louder?
1.
Yeah. What was the name of that identity, John?
It was the Pythagorean.
Pythagorean identity. That was the first one. Sine squared plus cosine squared. Now, they've got to be the same angle there, and these are. So sine squared plus cosine squared is 1. And well, where's that? Oh, sine squared beta, cosine squared beta.
Oh.
Also 1. Getting shorter all the time. The remaining 2 terms, minus 2 cosine beta cosine alpha, minus 2 sine beta sine alpha, both have a negative 2 coefficient. So if it's all right with y'all, with all of you, I'm going to factor out a negative 2 and write cosine beta cosine alpha plus sine beta sine alpha. Nick, are you comfortable with that factoring? All right. For the next step, I'm just going to add 1 plus 1. And I'm going to say my ABCs and put, instead of saying cosine beta, cosine alpha, I'm going to say alpha and beta. I'm going to put them in alphabetical order. So I'll say cosine alpha, cosine beta, plus sine alpha, sine beta. All right. Next up, transitive property. Transitive property says if this is equal to that, and if that is equal to the other thing, if this is equal to that, and that is equal to the other thing, then therefore the other thing is equal to this. Right, say it again. If A is equal to B and B is equal to C, then A is equal to C. So, back here from the law of cosines, I had this, 2 minus 2 cosine alpha minus beta, is equal to that, AB squared.
Oh.
Now I have this other thing, 2 minus 2 cosine, blah, 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 all that stuff, equals that, AB squared. So therefore, this is equal to the other thing.
Oh.
Agreed?
Math.
Because they both equal a b squared. So right here, instead of writing ab squared, I'm going to write 2 minus 2 cosine alpha minus beta. And on the right hand side, I'm just going to copy this down. 2 minus 2 cosine alpha cosine beta plus sine alpha sine beta. All right, and then with some quick algebra, I'll subtract 2 from both sides. So now those are gone. I'll divide both sides by negative 2. So that just ends up being, 1 over 1. So now I have cosine of alpha minus beta equals cosine alpha times cosine beta plus sine alpha sine beta. And that's great, that's a good formula. That is the difference formula for cosine.
So it's like a pain in the smile.
No. Alright, now that we are fully aware of how this is created and we can agree with every step so we know that it's true, let's use it to find that 15 degrees there, cosine of 15 degrees. Well, let's write it actually. Isn't cosine of 15 degrees equal to cosine of 45 degrees minus 30 degrees? Michaela, you agree, right? Okay, so surely these are the same thing, right? They are.
Oh. Math numbers.
All right. So now I've got this thing. I've got that 15 degrees rewritten as a way that fits this new formula. Okay, where 45 is my alpha and 30 is my beta. So based on that formula, I can just say cosine 45 minus cosine 30 is equal to the cosine of 45 times the cosine of 30 plus the sine of 45 times the sine of 30. I'll put a little dot. So this is how I use that formula that we just created. I rewrite this angle in terms of angles that are on the unit circle, and then I just fill in the formula. You might say, Mr. Geiger, this is not helping anything. Because before you had cosine 15 degrees, which seems like it's pretty simple. It's kind of like one thing. But now, I'm looking at 4 things. You can solve these no problem. Cosine 45, unit circle, go. Unit circle, not trig chart, or unit circle, not calculator. What's that? You are telling, that's 45 degrees. I want
My bad. Root 2 over 2.
root 2 over 2, the x coordinate, there you go, okay, root 2 over 2, got it. I'll put these in parentheses. Cosine 30, go. Root 3 over 2.
You got the next one. You got the next one.
Sine 45.
Sine 45. Root 2 over 2.
Somebody else, not from this area up here. Sine 30. Not too good. 1/2. Okay, a fraction times a fraction. I love this stuff. You just multiply the numerators and multiply the denominators.
Right.
Square root times the square root. Everything's under one roof here, so that's going to be square root of 6 over 2 times 2, which is 4. Square root of 2 times 1, I know that. That's just root 2. 2 times 2, just did that a second ago. That's 4. So according to this, the cosine of 15 degrees, I've got 2 fractions, common denominator already, take care of me, that's great, is the square root of 6 plus the square root of 2, all divided by 4. Don't believe me? Check it out. Ladies, cosine 15, enter. Guys, square root of 6 plus the square root of 4 divided, or plus square root of 2 rather, divided by 4, enter. Actually got an answer there for cosine 15, 0.9659.
9659258
Alright, that's good enough. Guys, do we have an answer on root 6 plus root 2 over 4? What do you get, Jeremy?
0.96592558.
Whoa.
Yeah.
We
Bet.
agree on something. There it is. The exact answer, ladies and gentlemen, of the cosine of 15 degrees. Brought to you by the cosine difference formula. Now, if it's okay with y'all, I'm just going to tell you what the cosine sum formula is without doing another derivation. Are you okay with that?
Yes. No,
Okay.
I want to do it. No, no.
Alright. Cosine alpha plus beta is equal to cosine alpha cosine beta minus sine alpha sine beta. Notice the difference
Oh,
there.
they're flipped.
Yeah. So your trig chart, folks, they want to be real clever and save some paper and save some ink.
Nice.
And they will write both of those on one line. All right? Cosine, but they don't use alpha and beta. Of
They
course,
use
they
U and V.
U and V, which I'm not a fan of because my U's and V's look a lot alike, but that's okay. But notice what they have here. Thank you. Oh, this way. From the office. Look there. What does it say? Plus or minus?
Plus and minus.
Plus or minus right there. Equals cosine. I'll make it like they do. Fine. Cosine U. Cosine V.
Then they have minus.
That minus then plus. Sine U. Sine V. That's not a typo. That's a righto. That's correct. That's the right way.
Yeah.
Why do they have minus and then plus, Rosa?
Because the second.
Or Rascal Rosa?
No, I'm.
You're mentioned a lot, Nia. Got any idea why the minus and the plus right here? What's that? It does look cooler.
Nice.
It also matches. Notice when there's a plus, then you've got a minus right there. So that plus corresponds to a minus right there. And when there's a minus, there's a plus right here. So the minus right there corresponds to the plus on that one. So position matters here. Depending on if you're doing the plus, then you're going to deal with the symbol over here that is on the top location. And if you have the minus, then you're going to be dealing with the symbol over here, which is in the bottom location, which happens to be the plus. Okay? Now, contrast that with sine. Sine u plus or minus v is equal to, look at the plus and minus symbols on that one. It's the same sign, so plus goes to plus and minus goes to minus with sine. Somebody tell me what else is different about the sum or the sine formula?
It's like sine, cosine.
Yeah, instead of cosine and cosine is sine.
Yeah, it's like alternating. It's like sine u, cosine v, cosine u versus cosine, cosine, sine, sine. Great. And then once again, if we wanted to, we could derive tangent. It's not that difficult, but we're not going to do it right now. If that's okay. If you want to be curious on that later. It's not even this involved because you just use the signs and stuff like that. But look at that formula. Tangent of u plus or minus v is equal to tangent u plus or minus v divided by 1 minus or plus tangent u tangent v. All right. So do y'all see how? Can you figure out how to utilize that? Probably. We'll verify that somewhat quickly tomorrow. Let's nope, not that one. Yeah. Let's do some problems together, shall we? Now, any problems that we don't solve today, we will solve tomorrow. I actually have all day tomorrow scheduled for solving these problems, so I wasn't sure how far we get. We're a little bit ahead, actually. Which is good. All right. As always, number one
It's not a good one.
is not a good number one.
Come on, Alex.
The rule of math learning, and this way is a learning of a lot of different things, is whenever you learn something, you want to then apply it just with a straight, regular, no frills, nothing fancy. Just give it to me the regular formula, how to plug that in. Then you can start doing the changes. Okay? You don't learn music by just improving all the time. You learn your scales and your chords, and you learn how to play songs with other people, and then you learn how to do the improv and go off on riffs and things like that. Same thing with math. All right? So here we go. Number 2. Find the exact value of cosine 165. All right? What we want to do is we want to rewrite cosine of 165 as the cosine of something plus or minus something else. Okay? I'm going to tell you use plus because it's a little bit easier, I think. And I want these two angles to be on the unit circle. So find two angles on the unit circle that add to equal 165. Write yourself a little note so that on Thursday night you can remember that. Or should I say Friday afternoon? Whenever you're working on the homework. These problems are a little bit longer than the space allocated on that paper, so you might need to just write these answers out somewhere else. Anybody found any numbers there? I'm hearing 120 plus 45. Let me do some mental math. Yep, that's 165. All right? And then, if it's helpful for you, you can label that as U, and that is V. And if you really want to, you could write the formula down. Cosine U, cosine V, minus or plus, folks?
Minus.
Minus is correct. Sine U, sine V. And then just plug it in. So cosine 120, cosine 45, minus sine 120, sine 45. And then we're off to the races. With your unit circle in hand, Stephanie, cosine 120. She says -1/2. Y'all agree? Michaela, cosine 45.
Root 2/2.
I agree. Haley, sine of 120.
Oh, there you go. Sorry. Root 3/2.
I agree. Somebody else real quick, sine 45. Root 2/2. That's right. Multiply the fractions. That's -√2/4 minus square root of 6/4. Oh my gosh. -√2 minus √6 all over 4. There's your answer, folks. Today we talked about why we need exact answers. We derived the difference formula.
Then one foggy Christmas Eve, Santa came to say,